This is the example for 4.3D, as in donut. All right. Find the concentration of HCOOH, that is formic acid, needed to form a solution with a pH of 6.29. So, first of all, we need to ask ourselves, is HCOOH strong or weak? Strong or weak? Let's go look. HCOOH is here somewhere. Or, actually, it's right there. But if you have trouble finding it and you're just wondering if it's strong or weak, you can look up here and go, oh, it's not one of the strong ones, and just leave it at that. But here it is, and its Ka is 1.8 times 10 to the negative 4. So I'm just going to write that down really quick here. Ka is 1.8 times 10 to the negative 4, because probably I will need that later. All right, find the concentration of HCOOH. I don't know if you recall, but whenever we talk about the concentration of the acid, HA, in the question, is that the initial concentration or is that the equilibrium concentration? It is always the initial concentration. So in this case, our unknown is the initial concentration of HCOOH. But we're still going to use all the same tools as we did before because it is a weak acid. We're going to use rice and Ka. So let's start by rice. R-I-C-E. And our reaction is HCOOH. I'm going to use water in here just so that you get used to seeing that. And we have HCOO minus plus H3O plus. And of course, water is a liquid, so we don't worry about it in our rice table. So we need to plug some stuff into our question here, and if we don't know the initial concentration of COOH, we can call that, if we want to, we can call it X. I think in the example on the page, we called it CI for the initial concentration, but there's nothing wrong with saying that it is X, as long as you don't do anything foolish, like assume X is insignificant. The original concentration of the acid is not insignificant. It's like 1.5 molar or 3 molar. It's whatever is undissociated. And remember, most of the acid is undissociated. It is not insignificant. The initial concentrations of the two ions are, of course, 0. We always assume nothing is dissociated when we start. And these, therefore, have to go up, and this has to go down. Now, I can't put X in here because I already have an X. That means I need to know one of the equilibrium concentrations. What else am I given in the question? I'm given pH is equal to 2.69. Well, pH tells me my hydronium concentration. So let's go and figure out what that is. So my concentration of H plus at equilibrium is equal to, and hopefully you remember, to find the pH, you take the antilog of the negative pH, or, if you prefer, 10 to the negative pH. And so that will be 10 to the negative 2.69. And I'm going to cheat and look at the answer, and that is 2.0417. 2.0417 times 10 to the negative 3, I think. 3, yes, molar. So this number here is now 2.0417 times 10 to the negative 3 molar. If I know an initial concentration and an equilibrium concentration, that means that I can find the change in concentration because I can subtract one from the other. And in this case, the subtraction is really super simple, and I just get 2.0417 times 10 to the negative 3. There we go. My other changes will all be the same because it is a 1 to 1 to 1 ratio. So this will be 2.0417 times 10 to the negative 3. 2.0417 times 10 to the negative 3. And so let's see, I now have x minus 2.0417 times 10 to the negative 3. Yeah, it's a bit of a pain writing all this down, but you know, we don't do too many questions like this all at once unless we're practicing. So you will be doing a bunch all at once. I'm so sorry. All right. We have done rice. Now remember the little week old lady walking along the street? She drops the bag of rice and the crow comes along and says, "Caw!" So we're going to do Ka now. And Ka is equal to our products, HCOO minus, H3O plus, over HCOOH. And we get, well, we plug in our values then from our equilibrium line, this one here, okay? And we have 2.0417 times 10 to the minus 3, and that is squared because I've got it both places here and here, over x minus 2.0417 times 10 to the negative 3. Now, some people would be tempted to say, oh, assume this is insignificant, but you don't need to because it is a real number. So don't assume that that is insignificant. That would just be letting yourself in for a rounding error later on that might cause you problems. Yes, so we now have, let's see, Ka is 1.8 times 10 to the negative 4. If I square 2.0417 times 10 to the negative 3 and then divide by, oh, what am I doing? Silly me. I should write this out first. 2.0417 times 10 to the negative 3 squared over x minus 2.0417 times 10 to the negative 3. Now, I'm going to tell you a little secret, and I tend to do this a lot, is that I will have a tendency, do not write this down, to do this. 1.8 times 10 to the negative 4 times x minus 2.0417 times 10 to the negative 3 equals 2.0417 times 10 to the negative 3 squared, and I will have a tendency to multiply this nonsense out. I end up with x terms and a complicated thing and a complicated thing, and it's way, way, way too much work. So if rather than multiplying this out first, if I then divide both sides by this bit here, then what I will end up with is, and essentially what I'm doing is I'm swapping these two. I'm bringing this one up and I'm bringing this one down. So we end up with x minus 2.0417 times 10 to the minus 3 is equal to 2.0417 times 10 to the minus 3 over 1.8 times 10 to the minus 4. And you see how I didn't have to do some multiplying that I would have otherwise done if I had just left it at that. So solve this bit here, and we get 2.3159 times 10 to the minus 2 equals x minus 2.0417 times 10 to the minus 3. And then x is equal to 2.3159 times 10 to the minus 2 plus, because we're bringing it to the other side, we have to change our sign, which was a negative. Now it's a positive. 2.0417 times 10 to the minus 3. And that is 2.52 times 10 to the minus 2. And that, if we look, what was x? X was our initial concentration of the HCOOH right there. Okay. And what did we want to find? We wanted to find the initial concentration of the HCOOH. So this, if I stick a molar there, I can say is equal to concentration of HCOOH initial, and I can put a box around that, and I am done. And thank you for watching this video on your Christmas vacation. You are lovely, lovely people, and enjoy the rest of your break.